Let's discuss about the worksheet of alkenes for AS level on 2nd July 2020. There are several questions and I give this one 3 pages. Let's see from number 1. Draw and name the geometrical isomers of pent-2-in. We note that if it has geometrical isomers, it means the structures contain double bond. Let's see here. This one, the number of carbon atom, there are 1, 2, 3, 4, 5. So it is a pentene. Let's see where the double bond is located. Double bond is located in at carbon atom number 2 and 3. So we can call this one is pent-2-in. And then the name, because the hydrogen atoms are located horizontally, both sides, left and right of the carbon-carbon double bond. So this structure, this isomer, is called as cis-pent-2-in, while this one is called as trans-pent-2-in. And then for for P, pent-1-in reacts with hydrogen bromide to produce 2-bromopentane as a major product. Outline the mechanism for this reaction. Okay, the major product is 2-bromopentane. It is not 1-bromopentane. Why? Because of the Markov-Nikov's rule. We learned that in Markov-Nikov's rule, hydrogen atom of the hydrogen halide will attach to the carbon that has already most number of hydrogen atom. Let's see in the structure here. There are two sides. One on the right hand side and the other one on the left hand side. The number of hydrogen attached to the carbon on the left hand side, there is only one hydrogen atom, while on the right hand side there are 2 hydrogen atoms. So because of high electron density of the double bond here that repels the electron in the hydrogen of the hydrogen bromide, so the hydrogen will become an electrophile, dipole positive. The electron of the hydrogen in the hydrogen bromide is taken by the bromide. That makes the bromide become a nucleophile. And then the hydrogen electrophile will attach to the carbon that has already most number of hydrogen atoms, which is on the right hand side. So as we can see here in the second, these two are called as the intermediate reactions. So this one, after the hydrogen is attached to the right hand side of the carbon, so the left hand side becomes carbocation. Carbocation lacks of electrons. So the bromide ion, which is a nucleophile, has an extra excess of electron. So the electron can be make dative covalent bond, can be donated to the carbocation that makes the structure become 2-bromopentane. Okay, and then identify the minor product formed in this reaction. The minor product is 1-bromopentane, which is not according to the Markov-Nikov's rule. So the minor and major product will form together, but most abundance is the 2-bromopentane, which is according to the Markov-Nikov's rule. And then B number 3. explain why 2-bromopentane is the major product. 2-bromopentane is formed via through the secondary carbocation. Look at over here. After the high electron density, we can see here there is an alkyl over here. This alkyl will give positive inductive effect to the next carbon atom. So that makes the next carbon atom will have tendency to become a carbocation, will become a positive ion, while this one, well, this CH2 is far from the CH3, and then so the carbocation, so the positive inductive effect will give the effect to the carbon. That makes this one is becoming the stable carbocation compared to the first one. After hydrogen attached, this one will become CH3. This is also will give a positive inductive effect to the middle carbon. So the middle carbon will become more stable. Next, let's continue to this number 2. Propene reacts with hydrogen bromide by an electrophilic addition mechanism, forming 2-bromopropane as the major product. Remember, again, this one is about electrophilic addition of alkene. So the equation for this reaction is shown below. Now, this one on the right hand side, again, there are 2 hydrogen atoms. On the left hand side, there is 1 hydrogen atom. So the hydrogen of the hydrogen bromide will attach to the carbon that has already 2 hydrogen atoms in it. The mechanism of the reaction, the intermediate mechanism, will be the same as I explained in 2-bromopentane, the same mechanism. And then this one gives the structure of the alternative carbocation, which is the minor. The minor, this one is becoming this one, the primary carbocation, not the secondary. The secondary is better. Okay, next, number 3. How do physical properties of the alkene homologous series change as the chain length increases? As the number of carbon atom increases, we know that each carbon atom, they have their own relative molecular mass. So if the number of CH2 or an alkyl increases in straight chain length, so the molar mass also increases. We know that if the molar mass increases, therefore the melting point increases. Why the melting point increases? Because it has stronger van der Waals forces. And then the melting point increases, then effect directly on the boiling point also increases. That makes the density. Density is mass over volume. We know here that the volume of the molecule would be insignificant, different to the other alkene in the same homologous series. It means that ethene and propene, they would have similar volume, but the mass increases. So we know that mass is directly proportional to the density. And then next, viscosity. Viscosity, it means the easiness to flow. So viscosity will increase. Viscosity will increase means it is become more viscous, difficult, not easy to flow like water. We know that example, the in real life example is the lubricating oil, or the alkene, it is in cooking oil. Cooking oil is called to be unsaturated alkanes. Okay, unsaturated hydrocarbons. This unsaturated hydrocarbons, it is the flow, it is not as fast, or the rate is not as high as the mineral water or only pure water. Pure water will be less viscous than the unsaturated hydrocarbon or alkene. Now number B, 3B. For the reaction shown in the equation, this one, name the process. The process for this one, NC2H4 become the fraction of the polymer. This is called as addition polymerization because it contains a double bond. If we draw the structure C2H4, so there is a double bond, CC double bond. It makes the CC double bond can break into CC single bond and then form addition polymerization. Next, we are on the last page. Most ethanol used in the chemical industry is manufactured by reacting together water and ethene. This one, ethanol, try to balance the chemical equation. Of course, ethene plus water become ethanol. The condition is 300 degrees Celsius and 60 atm or 60 megapascal or 6 megapascal. This one, the mechanism is electrophilic addition. All the ethene reaction, addition of ethene is always electrophilic addition reaction. Okay, and then number 4, last number, compounds with double bonds between carbon atoms can exhibit geometrical isomerism. So we have to draw the structure, the isomer of this one. Look at here, the same atom horizontally, and at the top horizontally chlorine, at the bottom horizontally hydrogen. Okay, so the geometry of 1.2 dichloroethene, one can form cis and one can form trans. What feature double bond prevents isomer 1 changing into isomer 2? What prevents it? Because it has restricted rotation. It cannot rotate. It does not have a chiral center, so cannot rotate the structure. So this is the discussion of the worksheet Alkenes 2nd July 2020.